So the queue has some applications. So if you are if you know about the waiting list, maybe in the real world application, yeah, the person will be in the waiting list. But in the online system, yeah, you can apply this one with the QADT, the bureaucracy. So if you apply some online documents, then yeah, you can have like this kind of queue. Or if you access to the shared resources printer. So in our room 203, we have the printer. And let's say the computers in our room want to connect the printer and everyone want to print, then it can be also a queue. And multiple programming. So if you are dealing with the distributed computing or parallel computing, then yeah, there will be some kind of queue application there. So in indirect applications, we can use the queue as the auxiliary data structures, and it can be a component for other data structures. In the queue, we can use array. Like in the stack, we can use an array-based stack. So in the queue, we can also use array-based queue. The array-based queue we usually say as the circular version. Circular. Circular means circle. There will be two variables to keep track the front and the rear. Okay. We have F, it is front, and R is rear. Array location R is kept empty. So we can see like this one is the front. This is the R and it will be empty. And the pink color means it is now the array with elements. The white color means the array without elements. So with this one, we can see that the front element is now in the index 2, 2, 3, 4. So it is in the index 4. And what is the rear element? So we have 5, 4, 6, 7, 8, 9, 10, 11, 12, 13. And R is in the index 14. Okay. We can have the wrap around configuration. It means if R is already at the end of the array, it will go back to the index 0. So that's the meaning by the circular version. So if R is now in the index 14 and we have another element here, so it is empty. We have another element here, so it is empty. We have another element here, then the R will go to the index 0 because now it is empty. So we call this is the wrap around configuration. Yeah, if someone or the front element is removed, then it will be empty. If it is removed, it will be empty. And then yeah, it will be always wrapped around. In order to find the number of elements in the array, we call the size, then we need to make some kind of formula. What is the formula? So this n represents the number of array size, and it will be minus with the front index plus r. And then we do the modulus with n. For example, now I have n equals to 70. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so the array can have 16 elements. The front is now in the index 4, and the rear is now in the index 14. Then what is the size of this cube? Then we can just do with the n, which is 17, minus the front index is now 4, plus the rear index, which is 14. Then the result will be 27. Okay. And we are going to do the modulo n. 27 modulo 17. What is the result? It is 10. Okay. We have 10 elements here. What about this one? So let's say after we wrap around, now the front element is here and the rear element is here. So how many elements we have in the cube? The same n, which is 17, but we have different f. The f is now in the 11. You can check index 3, 4, 5, 6, 7, 8, 9, 10, 11. And then the index r is 4. Okay, r is 4. So the same with this formula. Okay, you can just put the numbers 17 minus 11 plus 4. It is 10. And then 10 mod 17. Then we have 10 elements. This is the way to calculate the size. And if we want to check whether this queue is empty or not, then you will check if f equals to r. If the front element equal to the r, then it is empty. How if the queue is full? Then it will be there will be an exception. If I do Enqueue means there will be an object entering the queue. If the size is n minus 1, then full queue exception. Then you cannot enter the queue. It's already full. But if it is not, then let the queue at the index r can be filled with the object. And then r will be added by 1. But of course, we need to do with the modulo n, because there can be r can be in the rear part. So we need to use the modulo n. So you can see, for example, now I have the n is 17, and then the front is 4, and then the rear is 14. If I want to add one element in the index 14, then 14 plus 1 mod n, it will be the new r. So 15 mod 17, it will be 15. So the new r will be 15. And for the second one, it's the same. Now r is 4. If I add one more object, then r plus 1 it will be 4 plus 1 mod n. 5 mod 17, it is 5. So the new R will be in the index 5. Okay. If we want to dequeue means we want to remove. Operation dequeue throws an exception if the queue is empty. So if there is no element, there should be an exception. If it is empty, then it goes to exception. If it is not empty, then check the object. So I would like to remove the object which is from the queue in the index F. F is the front index. And then I need to change the front index. F plus 1 mod n. It will be the new F. And I will return O to show the dequeue. So the queue in Python use the following 3 instance variable. We have data. It is a reference to list instance with a fixed capacity. And then underbar size is an integer representing the current of elements stored in the queue. So this is as opposed to the length of the data list. And underbar front is an integer that represents the index within data of the first element of the queue. So assuming the queue is not empty. This is the array queue. And it assumes that we have the capacity like 10. You can do the init. It is the constructor. And we have 3 data. It is the data itself. We can fill with none. None means nothing. And then we want to put none for 10 times because it is the capacity that we set in the initial value. And the size is set as 0 and the front set as 0. Length is to get the size and is empty, yeah, if it is empty or not. And the first is, yeah, we want to check whether what is the first or what is the element in the front. If it is empty, then the queue is empty. If it is not, then we will get the index of the front, sorry, the value of the front. If we do the queue, yeah, you can see what we already learned from the pseudocode. This is the Python code. If it's empty, then give the exception. Queue is empty. And then, yeah, the answer is the front. Okay. And then we will give that this statement, self data front becomes none, right? Self data at the index front becomes none. So we want to empty that particular index. Yeah, we call this is to help the garbage collection. And then the front, the new index front will be +1 modulo the length. And then we will reduce the size. The size will be minus by 1. And then for the Enqueue, yeah, you can check the size. Yeah. If you still remember, array has size limitations. If it is already full, now in this case, we can make double. You still remember the growing array? Okay. Just want to remind you, in the growing array, we have two strategies, incremental and doubling strategy. Okay. In this case, we use the double strategy. We just double the array capacity. And then, yeah, we can do the same like what we see on the pseudocode. Run plus the size, modulo the length of the data, and then we will check. We will put the object E into the current or the rear index, and the size will be added by 1. This is the resize. It is to doubling the array size. So let's say I would like to make one variable old, and then I want to store all the data. And then the data will be known multiplied by the cap. The cap is the capacity that we want. So if we double it, then we will make known as much as double. And then we want to walk. Walk means we want to set for every of the element in the previous data into the new data. So the old index walk will be entered into the data index key. And again, we just use the formula walk plus 1 modulus the length in order to update the walk statement, the index from the old data. Okay. Because some of the data are not in the good index, not in the sequence 0, 1, 2, 3. Some of the data might be starting from the index 7. The front can be 7 and the rear can be 3. Then that's why we need to use this kind of increment. This is what you can see some of the application. There's one application, we call it Roundrobin Schedulers. And usually this is used in the kind of application in the queue, in the simulation, or in the manufacturing. We have the Roundrobin Schedulers. So we can implement this queue. Whenever we dequeue, it will enter the share service, and after we finish the share service, we will enqueue and it will enter the queue again. Okay, that's very brief information about the queue, and we also learn how we can implement it into the array-based queue. Next, okay, maybe I will show you a little bit about the queue. This is the code that I share in the PowerPoint, and you can try to run this. You can run this code, and then this is the example that I also give in the PowerPoint. You need to call the object, and then you call the array queue, and you will do enqueue, and then you want to get the length. You want to get you want to dequeue, means you want to get the front, and then it's empty. We want to check whether it is empty or not, the queue, and so on. Okay? So this is the same what I explained in the PowerPoint, but now it is the implementation. You can check what is the data. If you see on your PowerPoint, the first example that we have this one, 5, 5, 3, 5, 3, and so on, 7, 9, 7, 9. So it seems the index, it starts from 0 and 1 and 2. Okay. But actually, when you are using the queue, it is something like this one. The element 9, the element 4 is not in the index 0 because it is always moving. I give you this circle queue. Okay. Yeah, if you want to deal with the circular queue, it is one of the application that I mentioned to you. We can use the array-based queue with the one that you already saw before, or the circular queue. It is the application in the Roundrobin Schedulers. Okay, this most of them are similar with the array-based queue, but it has some more information about the tail and then about the head. So let's see with the next chapter about linked list. The linked list is another kind of data structure. And this data structure can be applied with the stack and it can be applied with queue. So we need to understand what is linked list first. Linked list is, yes, a kind of list, but we have a connection between the elements. A single linked list, we call it singly linked list. Yeah, this singly, in some of the literatures, they mention single linked list or singly linked list. It is a kind of data structure consisting a sequence of nodes starting from a head pointer. So we call this is node because in a node it can have many kind of values. The values here, it is so singly linked list is a collection of nodes that collectively form a linear sequence. So in the node, every node stores the element and stores the link to the next node. We call the first part is the head. And then we know that this element is A and it is connected to the next element, which is B. It is connected to the next element, which is C. It is connected to the next element, which is D. And at the end, it is connected with empty. So this means empty. The application, it can be related with the routing sequence. So if I want to go from Mohyun to Seoul, then there should be a sequence. From Mohyun, it can go to Gwangju, and then Gwangju, it can go to Hanam, and then from Hanam, it can go to Seoul. So it's a kind of sequence. And it is connected. Okay? Yeah, we can call it as a routing. And you can use also this for the delete or undo operations. If you are using the Word file or if you are using Hangul, when you delete or when you want to undo, okay, there should be a connection between those operations. Photo viewers. So they also, we can also use this one if you want to edit picture. When you want to edit some parts, and then if you put another part. So it is a kind of layer. We can apply the single linked list on those applications. And in the indirect application, it can be the auxiliary data structures. It can be for list, it can be for stack, it can be for queues, it can be for arrays. And it can be the component of other data structures. This is the node class for list nodes. So the one that I do not show you in the circular queue is about the node. If you check on the code here, you will see there is a node class, and yeah, this is about node. Let me explain this one first. When we have node class for list nodes, we have node class, and we have the private object element, and we have the private node which represent what is the next. So as you know before, the node represents two. What is the object and what is the next object? Sorry. So I hope that you understand this one. What is the object, the element of that object, and then what will be the next node? So the first, when I created this node, it will be null and null. Okay, no information about the first node. And if you want to create a node with an object, then you will have an element, which is E, and you need to give the information. What will be the next node? We can get the element, what is the element, and we can get what is the next element, and we can get, we can set the element, and we can set the next element. So for example, if I have a kind of routing, so I want to go from Rome and then I can go to Seattle and then I can go to Toronto. So it's like the travel plan. Then I can have this plan. Oh, sorry. When I have this kind of travel plan, for example, then I can say that the first is the head. And then Rome is connected to the next node, which has the element Seattle, and Seattle is connected to another node, which is Toronto. And after Toronto, yeah, empty. Then there will be no other travel plan. If I want to insert at the end, what does it mean? So I do not want to start from Rome. Maybe I want to start from here, Baltimore. Then I need to allocate a new node. So I make a new node, and then I will insert the new element. So the element will be inserted before the head, and then we will have a new node point to the whole old head. So this is the old head, and now we change, this is the node for being the head. So we need to update the head to point to the new node. How if we want to remove at the head? Maybe after I make a plan, okay, I do not want to go to Baltimore at the first, so I want to remove this one. Then you can update head to point to the next node in the list. So first we will set Okay, we want to set the next node as the new head and allow the garbage collector to reclaim the former first node. So this one will be removed and it will be like this linked list. So the original one is this one, and now it returns back to this position. How if we want to insert at the tail? Yeah, it is the same. We can allocate a new node. We can make a new node and then insert a new element and then have new node point to null. So the new node now it can be pointed into null and then have all last node point to the new node. So this point can be connected to the new node. After it is pointed to the new node, then we need to update the tail to point the new node. So before it is the tail, but now it is the new tail. Removing at the tail. Removing at the tail of a single linked list is not efficient. There is no constant time way to update the tail to point to the previous node. So if you want to remove this one, you need to check from all nodes, okay? Because we need to find what is the previous node, and then we need to move the tail to the previous node. And if we want to check what is the previous node, we need to check from the beginning. That's why there is no constant time. So we need to check from the beginning. Or we can say this is like n time. We can apply stack in the linked list. So if we use stack as a linked list, it is possible to minimize the operation. Maybe we can see from the previous one, if we use that kind of schema, then when we remove at the tail, it will be ON. But if we use stack, it is possibly to have O1. You know the algorithm analysis. When we do the algorithm, of course, we want to reduce the performance. If we can optimize the performance, that is the best. So we can implement stack as a single linked list. The top element is stored at the first node. The top element of this of the stack, it is the first node of the list. The space, of course, we have n, and then each operation of the stack ADT takes 1. So the first element is in the first, and then the next element is in the second, the next element is in the third, and so on. If you want to do like the linked list, so the linked list is the first we have the node. You can see from the previous section, from the previous page, we know how to make the node class. So we define the node. We have the element, the current element, and we have the next element. So when we construct this one, we need to have those two elements, the element and next, and then we construct. When we construct this one, the head is known, and then the size is 0. The length is it will return the size, and then it is empty, then the size is 0. So we know that the stack contain push and top. So what is push? Then we are going to push the node. Okay, the element is node. Then we are going to put the node into the stack. What is pop? We want to remove the node. Okay. And what is the node? So it will be the node which is in the head. Top is only to find what is in the top element of the stack. How if we want to apply queue as a linked list? So we can implement a queue with a single linked list. The front element is start as the first node. Okay, the front element is the first, and the rear element will be the last. The space used is on, and the operation of the QADT will take O1. So this is the linked list queue in Python. Again, we will have the node. It is identical to that link stack. And yeah, most of them are the same. We have the head and tail. And then we have the length. We have is empty. And then we want to know what is the first. So we want to know the head element. And we have the DQ and NQ. For the DQ means we want to remove the first element. For the NQ, we want to insert a new element. And based on those operations, yeah, it is 1, okay, O1. That's the singly linked list. And we have another data structure which is doubly linked list. In the doubly linked list, is similar with singly linked list, but the difference is only we have the link to the previous node. In the singly linked list, we just have the next node, but we don't have the previous node. We don't have the connection to the previous node. So here, the doubling linked list provides a natural implementation of node list. So we still use the node. And now nodes have the kind of position. There is a position. Later we will see what is position. And now we have three things. The first is the element. What is the element of the node? And then what is the previous node? And what is the next node? We call this first node is header, and the other we call it trailer. So we need to make this node. We need to make this node. So the special node is to specify that, okay, this is the header, and this is the special node to represent that is the end of the node, or this is the end of the list. The example is like music player. You can go to next and you can go to the previous one. Or if you are in the web browser, you can go back, forward. So it is connected. And undo, redo functionality. So after you undo, maybe you want to redo. So there should be a connection between those operations. Okay. Yeah, the only difference is only the connection to the previous node with the singly linked. If we want to insert a node, okay, when we want to insert a new node, let's say I want to insert Q. So I need to check what is P, okay, here. Let's say this is P, and I want to insert a new node after P. Then, yeah, it is, first we can just make a node, and this node has an object Q, and we need to assign the previous of this node into this, and we need to assign the next of this node into this, and then we will remove the link of the P which has the connection to the C. We will remove it, and we will also remove the previous element of this node. So the new will be like this one. So the step is just to cut the link and then insert the new link to the other nodes. What about if we want to delete? Yeah, when we want to delete, we can remove the, for example, I want to remove this P. Then we can just put the new, this is the trailer node, and the object here, the node here, will be connected to the trailer directly, and then the trailer will connect to this object, and then all the link from this P will be removed, and after it is removed, then we can remove this node. This is the doubly linked list in Python. You know the node, so I have explained before. In the node class, we can create a node, and then for the constructor, yeah, the constructor contains of header, header, and then we can set for the first time the next of the header is the trailer, and the previous of the trailer is the header. Okay, so this is only the first time, and then the size is 0. And then, yeah, we can have the length of the size, or this is empty. Insert between. Yeah. Now we are dealing with node. So if we are going to insert kind of node, then we want to insert the object or the element E, and we need to check what is predecessor and what is successor. So for example, it is a node. So predecessor is the previous one, and successor is the next one. The newest means I want to check the node. Okay, I want to create a node, and then I want to have the predecessor and the successor. And the predecessor next is the newest, and the successor of the previous will be the newest, and then the size will be added by 1. If it is about deletion, then the previous will be the predecessor, the next will be the successor, and then update the predecessor dot next to the successor and update the successor to previous into the predecessor. Reduce the size to 1, and then the element now becomes the node element, and we need to put as the none. It is just to duplicate or make the garbage collectors. Yeah, the performance of the double linked list, we have the space, which is on, and for every of the position, it is O1, and for all the standard operation, it can run for O1, so for constant. For the position list, okay, I guess I still need to explain more this one because of the time. Let me explain on Monday. Okay.